Hi, my name's Kit Franklin from HarperUniversity, and I'm here to talk about the Hands-Free Hectare and now the Hands-Free Farm projects. So, where I think we always need to begin is to consider, if we're moving forward with agriculture, what are the aims that we're trying to meet? Well, firstly, we need to feed a growing population with reducing resources. And that resource also includes people. If you take the UK for an example, we've gone from at the beginning of the last century, 2.4 million people working on farms to now around 0.6 million people working on farms, which represents just 1% of the population. We obviously need to use our inputs into farming in a more sustainable way, increasing efficiencies and reducing waste. And in order to do that, we should consider adopting precision farming, where we observe and measure, and then we make decisions upon variation, and we try and control that variation within our fields, doing the right thing at the right place, at the right time, and in the right way. But we also have problems that we have to consider within agriculture. We have reduced raw labour force, as I've already said, and at the moment that has led to an increase in size of machines. We have limited time windows in which to farm, as weather patterns have got more sporadic and farms have got bigger. Again, this has led to ever larger machines. And one-upmanship between farmers has also led to this. So when one farmer sees their neighbour has got a bigger, larger, shinier tractor, they are coaxed into doing the same thing and getting a bigger tractor themselves next time. There is a lack of resolution for precision farming, so we're trying to manage our farms in a precise manner, but if you consider the sprayer there at 40 meters wide, it can only manage the crop underneath it in a single 40-meter width. So we've actually got less precise in the years since precision farming was developed as a concept. We have compaction limiting our yields. If you look at the yield graph from the UK, you can see that since the year 2000, we've got a flat line on our wheat yields, and that is often caused by compaction. And I've obviously picked an extreme example where we can see a maize crop that's completely failed on a headland due to compaction. A small robot future. So academics for the last 30 years now have been discussing and considering the idea that if we didn't need somebody sat on every single one of our machines, those machines could be a lot smaller. If they could drive themselves and they didn't need an operator, they could be infinitely smaller and we could have many of them. And these swarms of robots would go out into fields and improve the resolution of our precision and therefore give us a marginal gain. They would reduce compaction because their size and weight would improve the soils, which again may increase yields. And as these robots would operate in swarms, they could cover the same area as the traditional machines in the swarms as they operate. These swarms would require management by a person and looking after, so we'd still retain the jobs within agriculture as we'd need someone to look after these robots. And also, if we're making robotic and autonomous vehicles, well, small is also intrinsically a safer vehicle. If it goes AWOL, it's going to cause a lot less damage than a great big quad-track tractor. If we look at the sort of energy implications of using these small machines to just treat every plant as an individual and maybe inject seeds into the ground, well, if we think about that method compared to ploughing a field where we would move 1,900 tons of soil per hectare, if we were just to inject the seeds using a small robot, we could move as little as 11 tons per hectare of soil. And that would be a dramatic 150 times reduction in soil movement and therefore energy potentially. Now, the problem with this picture is that to many farmers it seems very far-fetched and unachievable, and I considered that actually maybe the small tractor the size of the TE20, maybe 40 horsepower, would create some of these benefits. It would be more precise and less compaction, but in a much more approachable way for the modern farmer, because we all know we can farm with small tractors because we used to do it. So could we farm with small tractors again if those tractors drove themselves? And that's where the idea for Hands-Free Hectare came from. where myself and my colleague Jonathan Gill, who was using the open source community to develop drones, decided we would try to automate a tractor, a small tractor, using drone technology to grow the world's first crop. So rather than most university projects which start and stop at the development of a machine, we were going to develop a machine and then go and farm with that machine. We wanted to change perceptions, so we wanted to tell the world about what we were doing using real-time coverage and social media. And we wanted to utilize existing machines. We didn't want to reinvent the wheel. We were going to automate what already existed on our perfectly square, flat hectare, keeping things simple. And we had a number of backers commercially for this, Precision Decisions mainly as our main backer, but also a number of our companies backed what we were trying to do as a first experiment. We did this project for 2 years, and you're seeing a video here of our second year where the machine was actually improved, but I don't have enough time to take you through the full journey. So this shows our tractor operating, drilling winter wheat into our hectare, our perfectly square flat hectare back, and this was in 2017 and 18, although we started the original project in 2016. You can see we've grown a full hectare of crop. We're conducting all the operations, including harvest of that crop, to complete the full autonomous cropping cycle. And the final thing we did in our second year of hands-free hectare was to unload the combine on the move autonomously into the tractor alongside. So that was where we were a couple of years ago, and this project, as we hoped, was very successful, and over the course of the first 2 years we were able to improve the autonomy. And if you look at the image on the left hand side, you can see we have many misses and gaps in our field, and our tractor didn't drive particularly straight. And by the second year we'd improved things. We made the tractor drive a lot straighter, and the coverage in the field was greatly improved. Not only that, to come back to some of the earlier points of why autonomy might be important, between October and March, between October 17 and March 18, we had 117 days of 160 days of rain here in the UK and here in Shropshire, and we needed to put fertilizer on the 14th of March. All the farmers in our area were unable to put fertilizer on their fields because the ground was too wet and their vehicles were too heavy. Our small light tractor with its small light sprayer was able to go into the field and apply nitrogen, making our autonomous machine a more dynamic solution for growing crops. As we'd hoped, we ended up with good publicity, and that was all over the world in 85 plus countries. We had articles and news reports around our project, including some major newspapers such as the New Yorker, New China, the Hindu. So all over the world we created impact with this project, and we have a reasonable number of Twitter and Facebook and YouTube followers. The impact from the project was also political. You can see here Michael Gove, who's a very prominent UK politician who has visited our site, and in the background of that same shot on the left-hand side is also another politician, a more local politician to Harper. So we've had a number of politicians visit our site. We've also had chief scientific advisors and Her Royal Highness the Princess Royal has also visited us and talks about us in many events. So we've had a good political impact as well as a sort of just a social media impact with this project. An implication of what we did is that we could use our cheap open source technology to make precision farming more accessible. So everything on this tractor that you see in the picture here only cost £10,000 to make it autonomous, and you can include the drone for that. So it was a really cheap solution to automation. We've gone on to study the economics of the model that we produce, of our farming model. So rather than in a traditional farm where as the farm would increase in size, you would increase the horsepower of the machines used to enable one person to conduct all the work. In our model of what farming could be, we just buy an additional system. So we move from one system of small tractors to two, and then to three systems of small tractors. And what you can see is we've reduced the cost of production of wheat by around £30 per tonne. And now, if you consider that the average price for wheat over the last few years has been around £170 per tonne, what we've done is we've made small farms profitable. And that is a really critical advance of the system that we propose. Now, our current project is to move to a hands-free farm, where we wanted to escalate from our single small hectare to a wider land area more representative of a UK farm. We wanted to take on challenges such as swarming of our vehicles and negotiating roads and tracks. We wanted our machines to talk to each other through TIM type technologies, tractor implement management. And we wanted to maybe consider autonomous replenishment as well. This is the farm we've managed to move to. It's still on our university site at Harper Adams, but you can see is now made up of 5 fields and totals 35 hectares of land. Obviously 35 times the size of our original hectare, which is on the other side of our campus. We have a range of new machines working on this new farm. We have a slightly larger tractor, a few horsepower more powerful, and a slightly wider seed drill than our first project. We have a new combine rather than our old vintage combine. We have a Claas Crop Tiger, which Claas have kindly provided the project, and this actually comes from India, where its normal use is in rice paddy fields, but fits the size and scale of our project perfectly. And we've also received a sprayer from Amazon, which is larger and increases our output when we want to apply fertilizers and ag chemicals into the field. As we've built our specifications of our machines, we've tried to incorporate CTF into the system. So we have a 15-meter sprayer, a 1.9 meter drill, and a 1.9 meter combine cut, even though the combine's a slightly wider cut. So what we're trying to do is keep all of our tracks to a minimum, and we're down at around 50% of our field being tracked by the vehicles. Now that isn't as good as large scale CTF, which tends to be around 30%, but nonetheless with these smaller, lighter vehicles, we think that's a fairly good achievement. Here you can see the establishment of our first winter crop into the hands-free farm. This was a cover crop we originally planted in the field, so we had to first remove that cover crop by topping it. We then sprayed off that cover crop to give us a stale seed bed. So here you can see our sprayer in action. Before we did some light disc cultivation to incorporate some of the trash, which would allow us to drill the crop, the winter wheat, autonomously without any blockage issues. So this is in one of our fields. This is Middlemore. It's 10 hectares in size, and in total we've planted around 22 hectares of our farm so far, with autumn crops in September 2020, and we're now heading towards spring cropping, where we will plant a further 15 hectares of spring crops into the hands-free farm. So that's the sort of scale increase is quite significant, and you can see the fields have really grown, and obviously we're early in the process of farming. We've just established our crops, and going into harvest this year, we obviously have a much larger challenge than previously, with potentially 35 hectares of crop to harvest. Now, the implications then of what we're doing, if we consider the agricultural industry, well, we have Goldman Sachs predicting that agricultural robots or autonomous tractors, a smaller size autonomous tractor critically is what they've decided in this report back in 2016, could be worth 240 billion as a market by the year 2050. How long till commercialization then? Well, The project Hands-Free Farms are our partners that you see across the bottom of the page. Farm Scanning, Ag and Precision Decisions critically. They're hoping to get products out of the back of our project within the next 18 months to 2 years, where we'll be able to potentially automate tractors on farms commercially. But there's lots of people doing this around the world, and I know that there's many in Europe, but I've chose some further afield options to show here. So we have Kubota developing their own in-house range of autonomous vehicles based on their farming range. There's a company called Gus in the UK who are producing tens of autonomous spraying vehicles to spray orchards. And if you check them out, it's really quite impressive how many machines they're already producing. Swarm Farm down in Australia producing platforms to spray, as they say, in swarms. And Seedmaster or C.Run, which has now been bought out by Raven Agriculture over in the US, who are producing these fairly large, this image doesn't show that, but a fairly large autonomous seeding unit. So these projects, these autonomous systems come in all shapes and sizes, but they are happening today. What's the implication in terms of jobs on our sector? Well, we're going to need skilled fleet managers to work on our autonomous farms of the future, people who can adapt and run these new machines. We're going to need agronomists who can deal with all the remote sensing and data that these machines capture to aid their work, but potentially make their job a little more complicated. We're going to need cybersecurity, because if all our vehicles are interlinked and connected, then that poses an obvious cyber threat for someone to hack into the food supply chain. We need agricultural roboticists, experts in not only agriculture and engineering, but also robotics. And at the moment, I think this is an emerging sector of jobs, but at the moment it's quite small and soon will grow. We need communication and infrastructure developments to match and meet the requirements of these technical systems that are working in our country landscapes. At the moment, certainly here in the UK, communication in the countryside is relatively poor, so developing that is really important. Thank you very much for listening, and I'm now happy to take any questions. And for further updates, check out our various social media feeds.